As you likely saw in my previous videos, this is a scintillation counter and a CDV700 that connects to it, and if you turn it on, you get a nice random reading of radiation. Yes, there is a source nearby. Anyway, what we want to look at today is how this device works. So the top of this device is obviously a sodium iodide crystal that is doped with thallium, and this crystal little scintillations will appear, thus the name, scintillation counter. Scintillations are basically little flashes of light that are caused within this crystal by ionizing radiation. As you can see, this crystal, or more like the head of this probe, has a hollow end, so you can insert a probe into it, and it is surrounded by the crystal. But you cannot see this crystal, obviously. It's very sensitive to humidity. It will easily take up air humidity, so it must be very well shielded from any humidity. And the best way to do this is by providing a case such as this aluminum case, so we can't really see inside it. Now let's see. This is an actual scintillation crystal. You can imagine it to be in here. This is not hollow, so you cannot insert a probe, but you can imagine this to be the head of the scintillation crystal, as it is in here. And what you can see inside here, you can't really see much, but that is the actual crystal. That is sodium iodide doped with thallium. You can see it a little better if I show you a crystal that has actually been damaged. There was a leak somewhere, so it took up humidity, air humidity, and thus it began to discolor, and well, you can sort of make out the structure of the crystal. Let's try this again with a closer focus on things, and you can see it's a pretty clear crystal with slight contaminations in there, but it's very clear. This is sort of like it ought to be. And this crystal, on the other hand, is very discolored. You can see a lot of bits in it, and it's really yellow, so that's not the way it's supposed to be. That is quite broken. What follows next? Let's just take the intact crystal. What follows next after the crystal in this stage here is an electron multiplier. That is this thing. It is all sealed up, but you can somewhat see inside maybe. You can just see reflections of the camera, but I think you should be able to somewhat see inside if you focus on that. And this device will be connected to the crystal like this. It will be fitted really tight, and there's a little photocathode in there. So what happens is that ionizing radiation, like people falsely call it radioactive radiation, enters from this side and causes little scintillations or light flashes within this sodium iodide thallium crystal, and those little flashes of light will be registered by the photocathode that is in here in this stage, and the photocathode will thus release electrons, and the electrons will be accelerated by an applied high voltage such as 700 volts from this CDV700, and will be accelerated towards the anode and can then be registered by a device like this, like amplified and then registered and shown as counts impulses per second, for example, or impulses per minute, but well, you could even make it per second because it's highly sensitive. This device is highly sensitive. So that's how it works basically, but well, we can't really see inside here, but I actually put these crystals under an X-ray tube, and I will now show you why it is important that the crystal is sealed airtight and no humidity gets in, because it really causes an issue with fluorescence. So let's see. Okay, so here I am adjusting the X-ray tube to the actual field of interest, and you can see the contaminated crystal that well, took up air humidity on the left, and the intact crystal on the right, and in the middle there's a little uranium glass marble, which surprisingly did not glow up green if exposed to X radiation, even though it glows really nicely when exposed to UV radiation, which was a surprise, but Let's see the X radiation now. And you can see, very nice blue glow of the crystals. But the one on the right was glowing a lot more. Let's take a look at that again. So here we go again with a different angle. I'm adjusting the field of light again, which will be the field of primary X-rays. The other stuff you will see on the camera is just straight radiation, which inevitably occurs. And here we go, X radiation, and you can see the intact crystal on the right is much brighter than the one on the left. So yeah, as you can see, scintillation crystals are really sensitive to humidity, and you should protect them from it.